For today's lesson, our focus standard comes from grade 7, Expressions and Equations, Standard 3. Solve multi-step real-life and mathematical problems. Our topic continues to be from the unit Simplifying Expressions and Equations, Solving Two-Step Equations. Our essential question is, what are the proper steps to solving an equation for a given variable and showing our work? Please take a moment pausing the video if you need to copy down the topic and essential question into your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. So as mentioned in our essential question, we're going to talk about steps, although the tricky thing is you really have to analyze each equation that you're working on to determine the proper steps, but here are some general guidelines. First, start with the term furthest from the variable. Second, always use the opposite operation. And number 3, as a guiding rule, follow PEMDAS in reverse. This is just a guiding rule, and there are times that this isn't necessarily the case, but in most circumstances, it'll work. There are 2 analogies that I like to use when talking about how to solve equations. And here's the first one. We can talk about solving an equation, meaning trying to figure out what the value is of the variable, as being like unwrapping a present. So in this case, in this analogy, the variable is like a wrapped gift. We don't know what's inside of here, right? Just like with a variable, we don't know what the value is. And when we unwrap a present like this, or a gift, we unwrap it in the opposite order that the gift was originally wrapped. So first we remove the bow, and then we remove the wrapping paper, and eventually take the gift out of the box. So we're going to try and think about the variable inside of an equation being like that wrapped gift, and starting with the furthest variable, or the furthest term from the variable, which is like taking off the bow, and working each layer till we get to that variable. The other analogy that is helpful is to think about a balanced scale. So an equation is 2 equivalent expressions, so the expression on the left has the same value as the expression on the right, and that's just like the balanced scale shown here. We know they have the same value on each side of the scale when it is perfectly horizontal. Our goal in working with an equation is to always keep it balanced, and so what we do to one side, we must always do to the other. So you will hear me refer to both of these analogies, sometimes on the same problem, sometimes not, but good things to keep in mind. Please make sure you have this information written down before we begin our example problems today. Here's our first example. We have the equation 15 is equal to 3x plus 9. So in this equation, on the left, this expression is already simplified. It's down to just one term. On the right, we have 2 terms. The term with the variable, 3x, and the term without the variable, positive 9. So in this, we said that we always want to start with the term furthest from the variable. So we want to start here with the plus 9. And that is where we want to use the opposite operation as we try to unwrap this equation to figure out what this variable x, what the value is for that. So I find it helpful to draw a straight line directly down from the equal sign, separating the left side of the equation from the right, so that we can always make sure that what we do to one side, we do to the other to keep it balanced. So just as I mentioned before, we're going to start with this term, plus 9, because it is on the same side as the variable, and it is the term the furthest away from this x. So we're going to use the opposite of add 9, so that would be subtract 9. If we subtract 9 here on the right, we have to also move over here to the left and subtract 9. When we do this, This positive 9, subtract 9, well that makes 0. So that just cancels out and goes away. And what do we have left on the left-hand side? You said that 15 subtract 9 is 6. I would agree with you. And so now we know that 6 is equal to 3x. So we're getting much closer to that present, that gift inside. It's like we just took the bow off by subtracting 9 from both sides. So now we want to unwrap it. It's in that box with the wrapping paper on it. So x is being multiplied by 3. So we need to use the opposite operation to undo that. What's the opposite of multiplying by 3? Yeah, I agree. Dividing by 3. So we're going to divide by 3 on both sides of the equation to keep it balanced. 3 divided by 3 is just 1, so it leaves us with 1x, which is the same as saying x. 6 divided by 3 is 2, so now we've unwrapped that present completely to determine that 2 is equal to x. We can check this by putting 2 back into the original equation and checking to make sure that it's right. So 3 times 2 is 6, right? If we replace x with 6, plus 9 is 15. So we know our answer, 2 is equal to x, or x is equal to 2, is correct. In our second equation, we have 14 subtract 2y is equal to 36. So remember, we want to draw that straight line down. So go ahead and do that in your notes. So we have two terms here on the left, the 14 and the negative 2y. And we know that that is equal to 36. So we're going to leave the 36 alone for now. And the y is inside this term with negative 2, so we're going to start with the 14. Now there's no necessarily operation in front of this 14, but it is a positive 14. So what's the opposite of that? It'd be a negative 14, and as we've been learning in this unit, negative is also a way of talking about subtraction. We can use this symbol both ways. So we're going to subtract 14 from both sides. Go ahead and simplify your equation of what it looks like after we subtract 14 from both sides of this equation. After we subtract 14 from both sides, 14 subtract 14 is 0, so that just cancels out. We keep the negative 2y on the left side of this equation, and on the right, 36 subtract 14 is 22. So we're getting closer. Now we have y being multiplied by negative 2. So what's the opposite of multiplying by negative 2? Go ahead and try the next step. After we divide both sides by negative 2, we should end up with y is equal to negative 11. Because negative 2y, or negative 2 divided by negative 2, is just 1. And 1 times y is just y. So we end up with that 1y, y by itself. And 22 on the right divided by negative 2 equals negative 11. So in following these steps, undoing what is happening to that variable, we find that y is equal to negative 11. We can plug in negative 11 to our equation in place of this y and say that negative 2 times negative 11 is a positive 22, and 22 plus 14 is 36. So our answer, that y is equal to negative 11, is correct. I'd like you to go ahead and solve this third equation. We have negative 45 is equal to 4r, subtract 25. Go ahead and pause the video to solve for the value of r and resume the video when you're ready to check your work. Let's see how you did. We have negative 45 is equal to 4r, subtract 25. Since negative 25 or subtract 25 is the term furthest from the term 4r, the first step you should have done is to add 25 to both sides. If you add 25 to both sides, you should end up with negative 20 is equal to 4r. And since r is being multiplied by 4, our next step would be to divide both sides by 4. If we divide both sides by 4, then we should end up with negative 5 is equal to r. That's going to conclude our video for today on solving equations. Please make sure your notes are complete and be ready to practice more problems like this in class.